Hello students, today we are discussing in this topic about the basicity of the amines. So let's get start our interaction. The basicity of amines they show because of the amine can act as a nucleophile because nucleophile means a Lewis base because its lone pair non-bonding electron can form a bond with an electrophile. And second thing is that a Bronsted-Lowry base because it can accept a proton from a proton acid. So in this below the reaction of an amine as a nucleophile, in this reaction this non-bonded or lone pair of electrons are donated to the CH3 is the electrophile. Hence it acts as and the iodine is removed. Hence the nitrogen it acts as a nucleophile and CH3 is the electrophile. Again in second reaction you have observed that these lone pairs are accept the proton from the acid and the halide group is removed. Means this amino group is protonated. Hence due to these two reasons amines can act as a nucleophile or Lowry-Bronsted base. Due to this reason they show the basicity. Next is the amines are fairly strong base and their aqueous solutions are basic. And amine can abstract proton from water giving an ammonium ion and hydroxide ion. The equilibrium constant for this reaction is called base dissociation constant, symbolized by the Kb. So you have to remember that the stronger base have the smaller values of pKb. The basicity of the amines depend on the ability of the lone pair non-bonding electron at nitrogen atom to form bond with an acid. The more easier the lone pair electron form bond with the acids will make the amines a stronger base. First we see the substitution by alkyl groups. These are the some factors we have studied. So first factor is the substitution by alkyl group. The presence of alkyl group they are the electron donating groups such as methyl, ethyl, propyl, etc. will make the amine become more basic. For example, methylamine is more basic than the ammonia because methyl gives the extra electron cloud. Hence, the lone pair are easily available for the sharing. Hence, the substitution by alkyl group, they are very more basic than simple ammonia. Second factor is that the substitution by electron withdrawing group. First we see the presence of electron donating group. They are more basic than ammonia. But what about the electron withdrawing group? The electron withdrawing group means they withdraw the electron from the nitrogen of the ammonia. Hence there is the less availability of the electron to donation. Hence the nitroaniline is less basic than aniline. Means in this all two factors we concluded that the alkyl groups favor more basic than the ammonia and less favor in electron withdrawing group, more favor in alkyl group. You have to remember for MCQ points. Then we see the structure basicity relationship of amines. First we see that due to the electron releasing groups nature of alkyl group, that is methyl, ethyl, etc. it pushes the electron towards the nitrogen and thus make the unshared electron pair more available for sharing with the proton of the acid. Next is the moreover the substituted ammonium ion from the amine gets stabilized due to the dispersal of the positive charge by the plus I effect of the alkyl group. Hence alkyl amines are the stronger bases than ammonia. Thus the basic nature of aliphatic amines should increase with increase in the number of alkyl groups. As the number of alkyl groups are increased, the basicity also increase. Next is that this trend is followed in the gaseous phase only. The order of the basicity of the amines in gaseous phase followed the expected order. Tertiary amine first, then secondary amine, then primary amine, and last one is the ammonia. But in case of the aqueous phase, the substituted ammonium cation gets stabilized not only by the electron releasing effect of the alkyl group, but also by solvation with water molecule too. So the sequence may be for that the greater the size of the ion, lesser will be the solvation, and the less stabilized is the ion. The order of the stability of ions are as follows. In this, first is we see in the aqueous phase, the first comes secondary, then primary, and then tertiary. Okay, but basicity character decreases in secondary first, then tertiary, and then primary. Decreasing order of extent of hydrogen bonding in water and order of stability of ions by solvation. Greater is the stability of the substituted ammonium cation, stronger should be the corresponding amine as a base. Thus, the order of basicity of aliphatic amine should be primary, then secondary, and then tertiary, which is opposite to the inductive effect based order. Secondly, when the alkyl group is small, like CH3 group, there is no steric hindrance to hydrogen bonding. In case the alkyl group is bigger than CH3 group, there will be the steric hindrance to hydrogen bonding. Therefore, the change of the nature of the alkyl group, for example, from CH3 to C2H5 results in change of the order of basic strength. Thus, there is an interplay of the inductive effect, solvation effect, and steric hindrance of the alkyl group, which decides the basic strength of the alkyl amines in the aqueous state. The order of the basic strength in case of methyl substituted amines and ethyl substituted amines in aqueous solution is as follows. So, first come the secondary, then tertiary, then primary, and then ammonia. Again, this is due to the steric hindrance, the sequence may be changed. That is, first come the secondary, then primary, then tertiary, and then ammonia. Basicity of aromatic amines are: aromatic amines is less basic than aliphatic amines and ammonia. Reason behind that is the lone pair of electrons on the nitrogen atom is delocalized into the benzene ring. As a result, the lone pair of electron is less available for donation to an acid. The reaction is shifted towards the left and make aniline a weaker base than ammonia or aliphatic amines. Aryl amines versus ammonia. In this, pKb value we have to consider. So, pKb value of aniline is quite high. It is because in aniline or other aryl amines, the NH2 group is attached directly to the benzene ring. It results in the unshared electron pair on nitrogen atom to be in conjugation with the benzene ring, and thus making it less available for protonation. If we write different resonating structure of aniline, we have observed that this negative charge is delocalized, and these are the resonating structures. But for anilium ion, no other resonating structures are possible. Only one resonating structure. Hence, no other resonating structure possible. Due to this, we know that the greater the number of resonating structure, greater is the stability. Thus, you can infer that aniline is more stable than anilium ion. Hence, the proton acceptably or the basic nature of aniline or other aromatic amines would be less than that of ammonia. In case of substituted aniline, it is observed that electron releasing groups means electron releasing group means they withdraw the electron from the nitrogen atom, like they are the OCH3, CH3 increase basic strength, whereas electron withdrawing group like NO2, SO3A, COH, X halide group, these NO2, SO3 and acidic or halidic group, they are the electron withdrawing group. They withdraw the electron and they decrease it. Thank you.